Hello everyone, welcome back. Today we'll start a new series of videos and the subject for this series will be IS to IS routing protocol, which is intermediate system to intermediate system routing protocol. In this introductory video, we will have a quick overview of the IS to IS routing protocol in regards to where it comes from, what it does, how it does it, and then we will build from there. So first of all, let's check what is IS to IS, or it's also more commonly called as ISIS. So it stands for Intermediate System to Intermediate System Routing Protocol, and in ISO terminology, intermediate system refers to a router, whereas ES or end system refers to a host or a server or any endpoint. ISIS is an interior gateway routing protocol, which means that it is used to route traffic within the autonomous system as compared to routing traffic between autonomous systems like BGP. And like OSPF, it uses Dijkstra's shortest path algorithm to compute a shortest path tree. So friends, before we go further, let's have a quick review on the history of IS-to-IS routing protocol. So IS-to-IS was originally developed by Digital Equipment Corporation to support connectionless network protocol for routing the connectionless network service stack, and it was later adapted by the IETF in the year 1991, and IS-to-IS as a routing protocol was extended to support IP routing, so it was also called integrated ISIS and is now referred to as IS-to-IS. And it was later on standardized under RFC 1195, which is also called use of OSI ISIS for routing in TCP/IP and dual environments. ISIS was developed and written with extensibility in mind and continues to be used for new applications. For example, it has inbuilt support for routing IPv6, and it has ISIS extensions for segment routing, traffic engineering, and if you check in any of Cisco's recent developments, for example, OTV, ACI, Fabric Path, all of these recent technologies, they use ISIS as the underlay routing protocol or as a transport. So why should we use ISIS in modern day networks? First of all, it guarantees a loop-free topology, i.e. all routers in the network have the same view of the overall topology in that area, which is also called the link state database. It uses the Dijkstra shortest path first algorithm to calculate the shortest path tree to reach the various destinations or prefixes in the network. It is standards based, so it guarantees inter-vendor operations. So it's not tied to any particular hardware vendor. So be it Cisco, Juniper, or any other vendor in the market. So it works across platforms. ISIS also supports large scalability, and it is hierarchical in structure and uses levels for topology, and it is very similar or analogous to an area in OSPF environment, and we will deep dive into levels in ISIS in upcoming videos. And it also supports fast convergence through actively tracking neighbor adjacencies, and it only sends event-driven updates and doesn't flood the network with topology information or routing updates every few seconds. It has an efficient updating mechanism, i.e. it uses reliable multicast and unicast updates that are encapsulated directly at layer 2. So ISIS carries IP or CLNP routing information as a payload in its own packets. So ISIS encapsulates its packets or PDUs as we call it in the ISIS terminology directly in the data link header. It also offers control plane security, i.e. it supports clear text and cryptographic authentication like MD5. And as ISIS uses its own data link header, or as it's encapsulated directly at layer 2, it is much less vulnerable to attacks. So a man-in-the-middle attack is only possible if the attacker is on that link to intercept or send ISIS packets into the network. Also, ISIS supports both IPv4 and IPv6 in a single protocol stack. And this is where it differs from OSPF, because as we know with OSPF, we have OSPF version 2, which supports IPv4 routing protocol, and then we have OSPF v3 or OSPF version 3, which has the extensions to support IPv6 routing. But with ISIS, we do have support for IPv4 and IPv6 in a single protocol stack, which also makes it more efficient and scalable than OSPF. And ISIS was developed with extensibility in mind, with new extensions being added to the protocol as TLVs, also known as type length values. So support for IPv6 routing, MPLS traffic engineering, segment routing, fabric path, OTV, etc. were added to ISIS as TLVs, and this makes ISIS a very flexible routing protocol. And we will go over the structure of an ISIS packet in our upcoming videos. So friends, before we conclude this video, let's quickly discuss some of the similarities and differences between ISIS and OSPF routing protocols. So if we check the similarities first, the first similarity is that both are designed as standards-based IGP. So they are vendor neutral and they support all the hardware vendors out there. Just that ISIS was written for ISO, whereas OSPF was written for IETF. The second similarity being that both these routing protocols are link state protocols, and both these routing protocols maintain a link state database wherein all the devices in an area in OSPF and a level in ISIS have the same view of the topology. Also, both OSPF and ISIS use Dijkstra's shortest path first algorithm to compute a shortest path 3. The third similarity being both OSPF and ISIS use hello packets to track and maintain neighbor adjacencies. Also, both OSPF and ISIS have a two-level hierarchy. So we have a backbone and a non-backbone area in OSPF. Likewise, in ISIS environment, we have a level 2 versus a level 1 hierarchy. So even though we have the concept of areas in ISIS as well, but levels in ISIS is much more similar to areas in OSPF. Also, both OSPF and ISIS scales the network by hiding the topology between areas and levels, respectively. And we will go over scaling and summarization in ISIS in our upcoming videos. And both ISIS and OSPF are classless protocols, which means that both support variable length subnet mask and address summarization between areas or levels. And both OSPF and ISIS elect a designated router or a designated intermediate system to represent the broadcast network. So this feature prevents a router within an area or a level to establish adjacencies with all the other routers within that LAN, which makes the flooding more efficient. Also, both OSPF and ISIS support control plane security, i.e. they both support clear text, password and cryptographic authentication between neighbors. Also, both OSPF and ISIS are extendable or extensible routing protocols, i.e. both of these routing protocols have been extended to support MPLS traffic engineering and segment routing. So now let's quickly have a look at some of the differences between OSPF and ISIS routing protocols. So the first point being the encapsulation. So ISIS uses its own transport protocol and is directly encapsulated at layer 2, whereas OSPF uses IP for transport and it uses a dedicated IP protocol number, which is protocol number 89, for reliable transmission. The second point being OSPF has an admin distance of 110, whereas ISIS has an admin distance of 115. So all the other variables remaining the same for equal longest prefix matches. Both Cisco and Juniper devices will prefer an OSPF prefix over an ISIS prefix because of the admin distance. And as discussed previously, OSPF v2 only supports IPv4 and OSPF v3 supports IPv6 and IPv4, whereas ISIS can support IPv6 and IPv4 over a single routing protocol stack. And it uses a single shortest path tree for both IPv4 and IPv6. And this is where ISIS is arguably more scalable than OSPF. Also, in OSPF, the router ID is a 32-bit IPv4 formatted number, whereas in ISIS, the system ID is an ISO NSAP formatted hexadecimal number, which can be up to 20 bytes in length, that represents the node ID in the link state database. And the next difference being the packet formats in ISIS versus OSPF. So in ISIS, we call these updates or packets as link state PDUs. So in ISIS, the updates or acknowledgements are sent as LSPs or link state protocol data units, whereas in OSPF, we use the link state advertisements or LSAs. And as we discussed earlier, in ISIS we have the concept of levels, whereas in OSPF we segregate the network or the flooding domain with areas. And a level in ISIS network is closely analogous to an area in OSPF domain. Also, two routers within the same area can have either an L1 or an L2 adjacency. However, if they are in different areas, they can only form an L2 adjacency. And in the ISIS environment, we don't have the concept of a dedicated backbone area as we have in OSPF. So in OSPF, we have area 0, which is dedicated as the backbone area. But in ISIS, a group of contiguous routers in L2 areas form the backbone. So there is no dedicated area ID or area number for the backbone in ISIS. And talking about levels in ISIS, Cisco and Juniper devices run ISIS in both level 1 and level 2 router levels by default. So Cisco and Juniper devices running ISIS in the same area, they establish both a level 1 and level 2 adjacency, which results in these routers computing two separate shortest path trees for both level 1 and level 2, wasting resources on the routers. So it is a very common practice to change the level of these routers from running both level 1, level 2 levels to just run either level 1 or level 2. So friends, this was a high-level overview of ISIS routing protocol. We will go over the various protocol data units within ISIS in the upcoming video, along with the network type with its operations and configuration. So friends, if you like this video, please hit the like button, share the video with your friends, colleagues. Any feedbacks, comments, good or bad, are welcome. And if you haven't subscribed to my channel yet, please subscribe. But thank you very much for your time today, and I will see you in the next video. Thank you.